if we want to make AI topics being part of our everyday lives, we have to embed them in such a way that they become usable by everybody.
Welcome to a brand new episode of our podcast, Human and AI, Mind, Machines, and the Gradient Descent.
Thanks for tuning in again to listen and to geek out with us over the fascinating field of AI and the role of human. We are Uli and Abri, your hosts for this episode. And please let me introduce you to our genius mind today, Gerhard Kreß, the Vice President of the IoT Platform and the MindSphere Application Centers. Gerhard is a rare combination of business expertise and strategic thinking, together with technological excellence and a great stack of experience in operational management. I think that sounds already very promising. I guess we should just jump right into it. Gerhard, we're very grateful to have you on the show and for you taking some time off your busy schedule to share some of your knowledge and experience on our AI podcast. How are you doing and where do we catch you today?
So thank you very much for giving me the chance to be here on this podcast. I'm doing fine. It's almost a year in home office, so you find me in my cellar and working from here on. But the good part about all the topics that we're working on in IoT, it doesn't matter where you are. You can work in the office or from somewhere away. It doesn't really make a difference. And therefore, it's quite good to be working from home, having a good environment and a stable internet connection.
Yeah, that's true for sure. So you've been at McKinsey, you went to customer interaction to mobility, and now you're the vice president of the IoT platform. That's pretty impressive. So you've embraced quite some exciting experiences in your life. Can you maybe give us a brief sightseeing tour of your journey and share with us your main motivation behind it?
Yeah, I gladly do so. I think what I've always been doing is I looked into different topics and tried to enjoy the different challenges in front of me. And so therefore my way was not always a very straight path. So what you can see, for example, I mean, to paint the picture even broader, before I went to McKinsey, I did actually I finished a study in theoretical physics and then also in political science or international relations. This is totally confusing to any HR department, I can tell you. It's a lot of fun to explain that story. In between, I worked for an NGO. So I worked for a student organization in Brussels. And then after my second study in political science, I went to McKinsey working as a consultant, then went to my last client, which was Siemens Business Services, or later on called Siemens IT Solution Services, became an expert in call centers. That's also a great episode, I think, something I wouldn't meet today anymore. From there, eventually I moved on to corporate strategy in Siemens when the first discussion started on what does digitalization mean. We at that time still called it differently, but it was exactly those discussions. Went to corporate technology, was a colleague of yours, and then had the chance to really implement some of the thinking that we had in the mobility to build up a business around data analytics, or actually how do you use data from assets, from trains, to derive an insight that's relevant for the business. And as this was actually successful for the last 8 years, a couple of months ago, Ronan Busch called me and asked if I would want to take over and, let's say, implement some of the topics that we've done in mobility on a complete Siemens level. And that's how I ended up being headquarter again.
What a journey.
Yeah, I think it's an interesting journey, but I think the motivation for me behind all that has always been that I saw challenges that I liked and things that really interested me. I always tried to bridge between more strategic topics, like in McKinsey, like in corporate strategy, but also in operationally implementing that. After a couple of years in the strategic area, I usually grew a little bit unhappy and sort of wanted to move on to do something that is where you see a tangible result. One of the things I don't like about the strategy work is you end up delivering PowerPoint slides, but you don't do something that anybody can really touch. And therefore, I kept moving back and forth. And I think that's part of what I also say when somebody wants to go into this field, do something that you enjoy, because only then you can be happy and you can be good in that. And I enjoyed really pushing technology forward to how do you create something new for customers in an industrial field. I was never somebody who would be interested to going to some company looking at click streams in the web or something like that. Would never be my topic. I love also technological elements. I love machineries. When I was in mobility, we were in a locomotive factory. That's fantastic. I mean, that's sort of the metal nerd in me. And that combination was great.
I still remember actually the hackathon. I still own actually the hackathon T-shirt. Where you organized very early, pizza and hackish attitude. I love that spirit that you made, and also somehow the flavor you seeded there, right? In terms in Allah, there.
I also still have the T-shirt.
I clearly saw the passion route. But speaking of IoT, right? One of my favorite Twitter memes is actually, IoT is when your toaster mines Bitcoin to pay off its gambling debts to the fridge, right? It's some kind of awkward slogan, and I guess Bitcoin is pretty hippish currently, but it also shows, right? I guess the vision actually, of connected machines, right? Speaking to each other, and the communication with machines to each other, right? We are still very, very early in the race, isn't it? We're still a lot thing to catch up or actually to accelerate. Do you have any thoughts? How do we can we somehow accelerate this journey towards a more IoT-ish flavor?
Yeah, I think the first thing is, well, today the whole notion of IoT became, to my understanding, mostly that we talk about a sensor we connect to the internet, and then we take data to some central cloud store, and that's what we do. And this is only a very, very tiny portion of what we do. One of the big challenges for me is that these things out there usually have almost no processing power, so it's very hard for them to even start communicating among themselves. They have very simple protocols, and it's a point-to-point interaction most of the time. That's not using the full potential. But my bigger worry, and the question is, how can we accelerate that? It's not a technological issue. I think what we are lacking in the moment very often is the fantasy, but also the willingness to implement such a thing that shows why would that make something better. I'll give you an example. When you have a dishwasher that can communicate with an app and you can start that remotely, I mean, you still need to put the stuff in there and get the dishes out again afterwards. You can't do that with an app. So what does it help you to be on the road to start a dishwasher? The utility is, from my perspective, very limited.
Yeah.
And if these are our only examples out there, then of course, why would you invest in putting more capabilities in such a thing? So my concern is not a technology concern, but can we have this vision, but also then the detailed implementation to actually make such a few examples really happen, where you show there is a benefit in there. Why would you pay for such a thing if you don't see what it helps you to do anything better? And one of these discussions where this started was actually the whole thing of Industry 4.0. We have production lines that start to communicate among the machineries and start negotiating how you can run the optimal process under the frame conditions in there. But this is very difficult to understand and communicate. So I think we need to show a few clear visions. How is it making somebody's life better? Why is that a good thing? Otherwise, we end up having millions of sensors communicating to the cloud. We crunch the data there, and then we send some commands back, and life is good. This is not what IoT can be.
So we're missing a bit of the business models, I guess, right? Somehow on the one side, right? Making clear what's the transparency, what's the value actually added on to the customer side when they go towards this path, right?
Yeah. I wouldn't actually call it business model, even the business idea. So one of the things that has guided me in the last years is always asking, what is getting better for somebody? And why would somebody be interested in that? And if you can't formulate this business question or the value proposition, or you want to call that, if you can't formulate that in one or two sentences, then it's really, really hard to convince somebody to actually go along with it. And then comes the whole topic of business models, how you monetize. But I think you can invest already in something if you know that it creates a value. If you look at all the successful startups, many of them had no business model when they started, but they had something that made people happy, gave them something they really wanted. be it Facebook, be it Google, be it Apple, be it Tesla. The business models are evolving later on. And I would not be worried if you don't have a business model. I would be worried if it's not clear what is the value proposition. What are you doing better for somebody? And this is the discussion we're often not having. I'm getting really frustrated when we see IoT discussions purely on technology. People talk about IoT, you need that database. No, you need to know what you're doing. And then all the other questions are coming later.
But it's also challenging, isn't it? Because we, in the machinery or in manufacturing or, the industry space, right? You're dealing with a very conservative industry segment, right? It's maybe, it's not the deep expertise in technology. Maybe they don't need it. But as you said, you need to have some kind of value proposition also to expose, and this is sometimes not that easy, right? Exposing, what's the exact value, what they get, right? How do you see the world that on the one side we want to push towards more, data driven, data innovations, value enablement, on the other side, conservative markets? How do you bridge this world? Can you translate that? Is there a different language? Can I Google Translate? Techie manufacturing techie, or what's the actual?
Yeah, I think the biggest challenge from my side is two topics. The one thing is when we talk about IoT or we talk about AI topics, many of the customers, they don't know what this is, what you're trying to do there, and they're lacking the capabilities. So when we were working with our customers, we usually had a very large phase of teaching the customer what this new tool set is actually helping them to do. Because some of them don't believe in AI at all. Some of them believe it actually solves world hunger and child poverty and so on. And both views are wrong. It's a great tool for certain things. It's a really bad tool for other things. So when do you use that? So that's the first thing where we spend a lot of effort educating customers. You cannot do good business with a stupid customer. It doesn't work. The other part is then really translating that into the message. What is getting better for the customer? Why would that be relevant for the customer? And putting this into simple words. You cannot do a change in an industrial setting when you talk to somebody on the shop floor that owns a small part of a milling machine or something like that. But you have to actually talk to somebody who owns a part of a process and explain them, your world is going to get better this way. And this is a first start on that. So you have to convey a vision and in such a way that it relates to their work. The biggest challenge in my old role in mobility was to get the people talk into in the rail language. If you talk to them in the wonderful IoT glossy paper internet language, they wouldn't understand what you want from them, and therefore they don't trust you. So I think it's one side you need to educate them what this tool is, and you need to show them that there is something getting better, and they need to trust you that they want to walk that way with you. Because we all know if you implement something the first time, it's difficult and it's not getting better in the first couple of weeks. And I think this is the part where you need to take them along. There are some customers that are more open to that and they walk with you first, but then eventually the other ones are following up and opening up, and then you have the laggards that will anyway only move when it's too late. Yeah, but that's normal reality.
Then on the other side, if we're talking about industrial player, right? Everybody says yeah, that's the where the physical and the digital world emerges and fusion, right? Whether it's industry, infrastructure, mobility, and we're doing that with the partners, and that means in addition also, right, two different paradigms hitting each other. One is the IT, right, with cloud, with scalability, with software-centric mindset, and you have the OT, which comes with these reliability, security aspects, right? And I think also two different mindsets. Well, OT is I don't know if you talk electroplan, right? Different UX driven, right? How do you configure stuff, and different approaches? How do you motivate smart, intelligent applications? While the IT, right? What do you think is is that a race of IT and OT, or is it something which not is defined yet? Who makes the race?
Yeah, I think they will actually eventually merge. So out of IT and OT, you will get IoT. I'm pretty sure about that. But now, jokes aside, I think the part from my perspective is both sides contain elements that are worthwhile preserving. IT thinks in large scale. IT thinks about IT security, and OT usually doesn't. These are the people who come from the environment where security meant you put a fence around the machine or a fence around a train. Yeah, and suddenly you don't need that fence anymore, and they're worried. And I mean, we just had this thing. What was it, 2 weeks ago, when somebody in the US hacked a water utility and was putting some chemicals in the water that could have harmed people. So I understand that these are topics that we need to look in and ensure in the OT world. There's another aspect where I think it's getting really important. The IT world is sort of self-contained digital. The OT world is digital or becomes digital plus the real world. And suddenly the word security or safety has a different meaning. I mean, I spent now 8 years in the rail industry, and there's really about how do you protect people? How do you make sure you don't have accidents? How do you make sure that people are not getting hurt or eventually even killed? And if you take a wrong decision, you can actually really endanger people. If you take a wrong decision on the IT side, your IT system is down and you might not be able to billing, and that's really bad, but it's not as bad as killing somebody. So this is a different paradigm. And this also has an implication on the stability of systems. When you have an app and it crashes eventually, I mean, it's annoying, but it doesn't make a major problem. If you have a grid control software and it doesn't run properly, it crashes occasionally, like crashes once a year or so, you have a power outage. So we're talking about different paradigms, and very often I see that IT and OT are not understanding each other. But eventually, you cannot run an OT system with only IT technologies, but you can also not run it with only OT technology. So you need to combine it. That's why I said out of IT and OT, you will get IoT. And you see the first movements of that happening when suddenly a CIO in a company like Siemens asks about what do we need to do to become an IoT company, and starts thinking about how to set up the ERP landscape so that the IoT use cases can actually leverage that information that's in there to bring it into the reality out there. And you also need people who understand the physical world. So in my perspective, you have the people that have the IT, let's say, platform view. You have people who have the data analytics view, but you also have people who understand what certain decisions actually mean, because you have to translate whatever you do in your digital twin back into the real world. My example from the real world was always, it's real people traveling on real trains, and it's real people putting real components, repairing them in real trains. You don't do that digitally. You can play it around digitally to understand what you need to do, but if your ideas from the digital world do not manifest themselves in the real world, they're useless. And that's a very different thing than if you're running a simulation system for, I don't know, bias behavior in an e-shop.
Thanks for sharing. That's very interesting. Like really connecting the physical and digital world and the implications. Gerhard, what does the path towards pervasive use of AI and IoT look like, in your opinion, along the digital maturity level? So I guess the focus is still on asset indexing and monitoring, right? So what would you say? How can we really accelerate digitalization, and what can be done explicitly to improve the digitalization at shop floor and factory level?
Yeah, I think the use case of monitoring and combining data, that's usually the first one you think of. But if you really look at what's the value add you have there, it's in most cases pretty limited. And even if you want to then argue how much you're investing into connectivity technology, it doesn't pay your use case in most of the cases. The next challenge is that people then think about, oh, I do predictive maintenance. Oh, that's also cool, but it saves you a small portion of money. I mean, you can save 10, 15, maybe even 20% of maintenance cost. That's quite some money, but it's not huge. The type of use case that really make a difference is if you can, for example, come to the point where you say, can I improve the output or the throughput of a production line so that with the same assets you have, you can actually produce 10, 15% more. So basically, all the use case where the customer is earning more money and not just where they're saving money. These are the use cases where you normally have value that's about an order of magnitude bigger than what you have on the pure cost saving side. On average, there might be exceptions, but on average, that's I think is true. And these are the ones where you can really make a major difference. And if you only stick to the one I can monitor and I can combine information, I can see if this pump is working or not, that's a nice showcase to see what's in principle possible. But if you try to argue how much you want to invest, these things don't really have a good ROI. It gets really different when you say, I help the customer to earn more money, and from that I want to have a share. So unless we get to these type of use cases, it's always going to be an uphill battle, because you have to, in the IoT world, you have to invest first, also in hardware to get access to data, to transmit data, to aggregate that, and so on. You have to have your data platform ready. You get almost all the cost up front, and you get a benefit with each additional use case. And the ones that really pay back are the ones where the customer is earning more money. And unless we tackle those ones, there will not be a widespread adoption. I've seen many use cases where the ROI was so bad that the customer decided not to invest, or if they invested, it was for them to learn, and it was a POC from their side as well. And this means they will never scale it.
And speaking of use cases, so unlocking the power of AI in the B2B market has been quite in the focus in the recent years, at least. And thinking a little bit outside the box, are there any AI-driven innovations or breakthroughs that have inspired you and that you would like to share?
Yeah, I think for me, there have been a couple of really important developments in this whole environment over the last couple of years. The very first one for me was, obviously, taking the AI world as it was into account, the move to deep learning, but also for me, the most important element was recently that we had the first deep learning system that was able to both outperform the best Czech computer as well as the best Go computer. So you had suddenly a deep learning network that was not just triggered to one usage scenario, but could actually be, let's say, multi-usage focused. It gets more generalized or generic. This, I think, is the first step in a broad development, but we are going to see more and more AI technologies that are much less purpose specific, but they start becoming generic. I would want to call them intelligences, but generic actors and providers of insights. That was one big step for me. And I think Google has been driving that massively in their environment. The other part is these technologies only make sense if we can apply them in our lives. And what really has changed over the last years as well is that we get more and more applications that are enabled by AI, but you don't see that. The best example for me is the iPhone. If you take the latest iPhone 12 and you make some pictures, you get incredibly good images there. But about half of what they do to the image is AI. It's running in the background. It's making sure you get what you want, but you're not going to see it. There's not going to be a label on it. You need AI now, and it's doing this. Or some photo manipulation software environments I just recently downloaded, where you basically point to what you want to have changed, and then it adapts it for you. This requires an awful lot of AI in the background, but it's not coming up as, oh, we are using AI now. No, it's becoming part of the fabric of how you process an image. And it does intuitively what you want it to do. This is the way how suddenly these technologies, I think, will get a very broad adoption.
Yeah, they even call it computation imagery, computational sounding, right?
Yeah. I think that the big breakthrough is there when you do not see AI being at use, but it becomes part of what you want to do, because you're not going there because I want to do this, therefore I need to use AI. No, I want to do this. How do all these tools help me to deliver what I want to do? And if this embeds in your normal workflow, then it's great. But this means it's an awful lot of work around the AI model to make it intuitive, simple to use. I think it's more work than developing the model itself, a lot more work. And you see the first examples where this is happening, where AI becomes part of the normal functioning of devices around us.
A very interesting perspective. And Uli, you were also saying that AI will always be part of the solution, right?
No, it will be part of the chain, isn't it?
So, Gerhard, you just mentioned how crucial actually AI is and how much more it will be part. How do you see the role of AI currently in our organization? Can you maybe share a couple of interesting use cases you have been working on that you're particularly excited about?
Yeah, I think the role of AI across Siemens overall is by far not as prominent as it should be. I'm very, very, very glad that the AI lab exists, because this is for me one of the big steps towards bringing AI to many different use cases where it makes a lot of sense. I think we are having by far not enough AI expertise in the businesses to understand really how we can solve a customer problem, how we can really operationalize the things we're doing there. What are use cases I'm excited about? I think, as I said before, I talked about going away from the monitoring and the predictive type things or maintenance type topics. There's two things I've been working on the last year that really I love very much. The one of them is we're just having a discussion with a very big rail operator, and actually a project that is already running, but I'm not yet allowed to talk about that, where we help the rail operator with the existing fleet to deliver 10% more rail journeys or rail connections, trains running in the schedule than what they have originally planned. This means they can transport 10% more people. They can run a much better train schedule without having to acquire any new trains. And economically, that makes a lot of sense for them as well. I mean, for the passengers, it's great because you're going to be much more on time and you're going to have more connections to choose from. Economically, for the rail operator, it's great because they have already bought all these assets and now they can get more people to use them, and therefore they earn a lot more money. For both cases, it's great, but this is the first time we have a use case where we are translating all these prediction capabilities into a guaranteed availability that you can rely on as a customer, and that really help them to change the schedule so they can deliver better what the passengers need. The other part is where we very often talk about AI and IoT being separate software solutions. I also believe that these technologies are going to be embedded in hardware systems and make a difference. Again, a red example, the new trains that Siemens delivers for the Victoria line in London, the so-called deep tube trains, they have an incredibly high expectation on reliability of the trains, actually almost double of what the current trains that are running on that line are having, which means 150,000 miles on a fleet average between two delays of 2 minutes. This basically means that you have a delay every 1.5 years or so. So that's pretty good. And it's very important for a metro line because you're running at very short cycles, many trains behind each other. If one of them has a technical breakdown or a problem, this creates knock-on effects, and basically you have probably a few 10,000 people who are not reaching their destination in time and actually going to be very much delayed. So that is a very big, clear requirement. And actually for those trains, this is factors away from what you normally can deliver. So we decided jointly with the rolling stock colleagues to actually implement AI technologies into the train to make sure the trains are condition aware and they can basically inform the maintainer, which is the customer themselves, about all issues coming up anytime soon. So they're not going to fail. There's not going to be any surprise. And the reason why I like this is because it's not an aftermarket service you do for some assets, but actually you make an existing asset, a train, a lot more versatile and a lot better by embedding these technologies into the system.
Nice. If I may ask, so if we observe somehow the last years in the development, right, on a journey being more, maybe AI first driven, right? Then one can identify also that we have in the lab structure, you start with engagement, with maybe inspiration aspects, exploring the capabilities of AI, maybe then starting over, taking with businesses prototypes, of geeks together. Then you start prototyping with business together. And now we see this drive towards more co-exploration of potential with end customers, meaning, also making sure, okay, this is a journey for both of us. Let's do that together. Let's co-explore, if you want to say it, right, these solution and build this solution together, right? How do you see this trend? This is super challenging, I guess, for all partners, right? Because it's not something that you buy out of the box, but it's something where, it needs to be a win-win for both parties or for three parties together. How do you see this co-exploration, co-creation aspects in the field of AI?
I think it's important. One of the points I mentioned prior was that it's very much about educating the customer to understand what these tools technologies can really do. And part of this core exploration means that you bring together the best knowledge that, for example, we have on the Siemens side, but also on the customer side. The customer always know their processes better than we can ever do. The customer always know better what the implications are for their business. So bringing that together, I think, is very powerful to actually get something that is useful, to educate the customer to understand where else these technologies can help, but also to make the customer trust what we're coming up with. If you have a linear rule, like if A happens, then you should do B, that's pretty simple. And everyone understands why that makes sense, and that's what we've been living with. But here we talk about if you have such a diffuse picture and you have these things in your feature vector, then your neural network is going to tell you to stop the train for whatever reason, or to exchange a component, or to drop that piece out of your production. These things are not so straightforward anymore. So you have to trust that these things actually make sense. And if you're part of the development process, then I think you can easier create that trust than if you just get a piece of software and say it's going to work. Well, it might not, and you just don't know. So I think in the moment, this is what we need to do. But I believe we must not stop there, because if we want to ever see this whole thing as a business, we cannot always co-explore. Eventually, we have to come up with products and productized offerings that you can scale to many customers. Otherwise, this will never become a business that you can earn money with. So yes, in the moment it's important, but we have to make sure that this doesn't become the standard operation mode for the next 10 years, but that we extract these elements that you can reuse, that you can actually package and scale to many different usage patterns, and really create your product core out of that. So yeah, we're on the right track, but it should not be the end game.
Yeah, but one of the questions which I have a bit, because I talk quite with sales, because I think it's about time putting AI in practice. It means also in operation, right? And so if you start with a modality like let's co-invent or co-create together and build these things together, the sales department, right, says like, what the heck should I sell now, right? How do I make that a value proposition to the customer, right? And I think that's a super challenge for the sales unit, because I mean it's the key strengths mostly of large orgs, right? Is to present values of products, value of services, right? How do you incentivize these kind of co-exploration aspects, right, to the stakeholder? Any nice trick you want to share here or can share?
It's very difficult in the end. If you have co-exploration, this is nothing you can scale to hundreds or thousands of customers. You're not going to have a sales force selling this thing. You have to afterwards extract something from there and say, these are 5 or 10 elements that I believe can be applied to any customer. And then you package them and you start making that sellable to a broader sales force. If you're still in this mode of co-exploration, you need a very small sales force. That sales force needs to understand the value you're creating and also the uncertainties. I mean, this is, if you co-explore, it means that you're not 100% sure how the outcome is going to look like. And what I've learned a lot is that you don't have then a classical sales force out there in the field, but you have people, sometimes even data scientists or let's say product manager, or people who are a little bit less technically geeky, but you have the analytics team doing a lot of the selling when it comes to the details. So you have the sales force opening a door to a customer, but you then in the workshops have the people who really know, because also part of the selling is you need to trust your vendor that they can deliver. And very often it's very good if you have somebody sitting there saying, I'm the guy who is going to do this with you, and you impress the people. That's how we sold Reams in Singapore. Michael Taylor went to the customer, explained to the customer what can be done, showed them where he was already, showed them some real things, and they trusted him. And that's one of the the key reasons why we won the Reams project. And now he's down there delivering, and the customer loves it because he just didn't promise something, he also delivers.
Yeah, Michael is a great guy.
Exciting. Michael Taylor was awesome.
He should be. He is, for me, he's a role model, an absolute role model.
Beautiful. So as data fusion is driving the value in AI and ML in corporates, what would you say are the fundamental pillars of a corporate data strategy? So how does that look like, and how can a company really effectively leverage its data assets?
That's a tough one, huh?
It's a very, very important question. But I think the first step is to understand what on earth are your data assets and what can you do with them. Because I think we totally overestimate what we have as data assets. Because most of these things that we have access to belong to somebody else, or they have other limitations that are there. So I think the first part is understanding what on earth do you have, and it's going to be less than you think. I'm pretty sure about that. The other part is data alone doesn't make any sense. You have to be able to combine and connect data. So that's why I'm so adamant about all these technologies where you, knowledge graph and so on, semantic technologies, where you try to make very diverse data sets accessible. I think in terms of data strategy, all these silo approaches are pretty stupid. You have to have a way to access data that's not directly coming from your domain, because some interesting questions against that data set or combining data sets can lead to new insights that might be really, really useful. I believe that we need to have not only clarity of what data we have, but also where do we have it and how do we access that. Trying to get data that is not in your domain can take weeks. We just had with a customer that we knew what the data was, we knew where it was, and it took us 2.5 months to actually get a copy of a portion of it. That's in inside. I mean, this was not with the customer. Try to do that now inside Siemens, it will not look that much better.
Yeah.
If you even can localize who on earth has that data about that building complex somewhere in South Australia, who on earth sits on that data? And where is it stored? Good luck. You're going to come back 3 weeks later, and by that time, the question is obsolete. So from my perspective, we need to have an open way to access it, or at least to find it. You still will have access restrictions in some cases, but you have to have a way to at least know what you have.
Do you think we have certain roles, data-centric roles, actually, some kind of operation model? Is that, I've seen on other corporates, right, they put like CDO in terms of chief data officer at the very first, right, to have this power in large orgs, to incentivize. Do we need certain roles in that? Or do you think it's not about naming somebody a chief data officer or, stuff like that, but it's more roles distributed in the orgs? Any thoughts on that?
Yeah, I think what you need is you need people who live such roles. We also call them data stewards or whatever. I mean, basically, you need to, first of all, understand where your data is. You need to work to make sure the data is sort of meaningful and it's of certain quality. I'm not saying high quality because I believe on big data topics that's almost impossible. But you need to look at the quality of data. You see always changes in those things that are delivering data. And suddenly stuff that was good yesterday becomes pretty useless the day afterwards. So you need to have somebody taking on that role. And in Siemens, it's in different businesses, probably different people. If you have to name that role on the org chart, I'm not sure. But the other part, when you ask about data strategy, is you have to be very clear. When I talked before, what you have is what I call raw data. There's a lot of derived data that we also have, where the ownership structures are a lot more simpler to define, and we're totally not aware of the value what this is. To give an example, if you look at a certain component that's failing, you don't need to have every single failure pattern in the work orders. But you can, for example, extract from there, let's say, the failure risk profile curve. And that's something you have to keep, because that's something you can do over a whole fleet of similar things. And suddenly they give you a new insight how you engineer your components. So these derived information sets, they can be as valuable or even more valuable than some of the raw data. And in the moment, nobody's keeping track of those.
Yeah, great thought, actually. There's also quite some hip actually on what's called AutoML, right? So a bit of the trend towards self-service, low code, easy to use. AI will be the Excel of tomorrow, right? Let's say you enablement an audience target group of AI enthusiasts, right? Which maybe not into depths, but want to leverage the capability. So, and apart from obviously AutoML as automating I don't know, neural architecture search, it's also about somehow automating the data science pipeline on it, right? With quite some expectation, right? This will we don't need any AI geeks anymore because this will be all AutoML, right? Being done. What's your view? I'm interested here.
Oh, I think it's a great vision. We're very, very, very far away from that.
Why is that?
I'm not trying to make a joke about it. I think as a target, it's good. And if we want to make AI topics being part of our everyday lives, we have to embed them in such a way that they become usable by everybody. And this is still a lot of work to do. My biggest worry is not that you can automate the machine learning process and around that. The first big question is the whole data preparation. How do you extract your features? In most of the industrial IT systems, you have factors more sensor dimensions than you actually have physical dimensions that are influencing your asset. So how do you deal with that? Dimension reduction in the data set. I think this is the part where AI still is an art and not just a craft today, or applying AI. Yes, eventually I think we're going to be able to solve that. But I believe we're not there yet. I believe there will be a big drop in enthusiasm when people realize how difficult this thing is. I love this Gartner hype cycle. So when you have this trough of disillusionment, and we have to go through that still on AutoML, still there are for certain areas already some good things around. And I think as a target, it's important. If we want to have AI becoming part of the fabric of how we deal with things, we need to crack that nut.
Bold vision. So there's an ongoing discussion about why organizations are having a really hard time in scaling proofs effectively. So from your perspective, what are the biggest obstacles that are preventing AI from becoming productive? Can you maybe share some best practices out there?
Yeah, I think the first part is that, especially with these AI topics, you're selling to top management. And then they see a proof of concept, and then you try to explain them. Now it takes, I don't know, half a year or a year or whatever to build this thing proper. But I've seen it already, it's there. And the difference between it's there as POC and it's there as productive is still very hard to explain to management. I had my fair share in trying to do so, and I have not always been successful. So I think this is the first big challenge. The other part is in the POC, you're trying to resolve a certain type of the question. Like you want to show that you can detect certain obstacles. When you want to do it productive, you want to make sure that, or you have to actually prove that you can detect every obstacle in any environment. That is a lot more work on that, especially when you're dealing with environments where safety critical elements are in there. So you need a lot more stringency in making sure that you know exactly what your model behavior is and what the data is that you trained it on, if there's a hidden bias or not, and what type of bias there is, and also what on earth this model learned, and so on. So I think this is the part where there are many questions still unanswered. I remember this example when Daimler tried to or played around with autonomous driving, and then they had this, or they trained their models by simulating environments and creating beautiful imageries, and they played around with lightning and so on, and then they saw that there was this picture of a street crossing. There were some holes in the concrete, and it was reasonably dark, and suddenly that night vision system believed there was an elephant there. Now, there's not going to be many elephants in downtown Sindelfingen, but of course, they didn't know why on earth this thing happened. But you have to play around with all these different scenarios, and then you eventually find the quirks in there. And especially when in the industrial setting, the consequence can be a lot bigger than if you're doing something on a website and you propose the wrong additional things to buy or whatever. In industrial settings, you have to implement this and change a real process. And therefore, you want to be sure that it's safe enough, good enough. And that is a bigger challenge. So the cost of a misprediction can be much higher. And therefore, it is a difficult environment. Very difficult to test something out because you might damage something that you don't want to damage.
Yeah, the industrial grade makes it a bit more different stream, right? That the consumer's trend.
Yeah, I mean, my example is always when you say, I have an 80% prediction accuracy in Amazon when it proposes you books, and you bought these books and the other 10 books that you could buy. I mean, you would be happy if 5 of them are right. If 8 of them are correct, it's fantastic. Would you see the difference between 8 good proposals out of 10 and 9 out of 10? I think the additional value is almost zero. You wouldn't see that. If you take a train door and you have an 80% prediction accuracy, this means you're generating 20 times as many false alarms as true alarms. So this thing is totally useless. Absolutely off the scale. You can't even touch it. So yeah, because these assets are failing very seldomly. So you have to have a good prediction accuracy. And at the same time, you have enormous failure costs. If an Amazon suggestion is wrong, you just click it away or you don't even look at it in depth. It costs you 2 seconds of your life. It doesn't matter. In the other case, you actually, it costs a couple of €1,000 and you actually take a train out of circulation. So that's a very different thing. And this is the part where experimentation is so difficult. And we need to find a way to experiment there. Otherwise, we cannot get these things really into full production mode. Or we need to find other use cases where the failure costs are very little. That's why, for example, in a lot of the productive use cases in mobility, we actually played the result back to an expert. So what the big step forward was they didn't need to look at all the data from all these trains, but we actually gave them every day 5 things to look at. And sometimes 4 of them were still not an issue, but we asked them basically for like 15 minutes of their time every day. And that was something they could afford. And then they found this 1 or 2 things where they would really say, now we have to initiate an action. So the first step was very often just this pre-filtering and giving you relevant information, because otherwise you would have to look through all the data, which you wouldn't do. But even if you would do that, it would be most of the time pretty boring.
Yeah, I love that.
Thanks for sharing, and thanks so much for your time and for being with us, because we are already at the very end of this session. We could talk to you for hours. But before we finish this episode, we want to play Authentic Autocomplete with you. So let me give you, for the closing, a couple of sentence starters and you will finish. Are you ready?
Okay.
So Siemens is
a great company with huge potential, but not being aware of its potential and not using it correctly yet.
I like that. AIoT is
the ideal combination, the only way to make sense out of all these things in the world.
Beautifully put. Innovation is
bringing great ideas into practice and making a difference for real human beings.
Nice. The world should have more of
the willingness to take risks if you believe in something. And the other part you should have more of, I think, is trying to make the world a better place and always thinking, what can we do? What can I do to make the world a better place?
Wow, I like that. And last but not least, if I could invent a rule for everyone in the world to follow, it would be?
Don't ask what the world can do for you, but what you can do for the world.
I've heard that before. Hey, go, Gerhard. Thanks so much for spending the time. I think this is the longest episode we ever had, but I have the feeling I would have another 100 questions, and it's so fun, insightful, and passionate engaging with you for throughout the years actually, and I hope we continue these kinds of really open, direct discussions in the future. Thanks so much for spending time with us here.
Thank you very much. It was a pleasure for me.
And folks out there, stay tuned. There's a lot more to come. I don't know what, but there will be. Stay bold, committed, and open-minded. And we hear us at the next Siemens AI Lab podcast. Thanks very much.